Hello everyone. So in this lecture, I will be working with the AI director. But before that, I want to actually address an issue. Um, it's not actually an issue. It's the system that I am making over here, the free flow combat system. It's basically animation based system. Okay, so that is why in BP player we have this free flow combat component, right? And we have these animations, we have the play rate and the offset exposed, right? So the reason I have this play rate exposed is that we can actually like make the animations a bit faster or comparable to the other montages that are being played, right? So that it doesn't affect animations as such that one animation is faster than the other or one is slower than the other, heat reactions are slower and stuff like that. Okay, so that is one thing to understand about the system. And second thing, uh, I think I've said this before, but again, if this is your first project that you are going for in Unreal Engine, it is a very bad choice. Okay, now you might think like why I'm saying this and that I shouldn't while I'm teaching, but it's a fact. I mean, there's a reason not a lot of videos are there for free flow combat systems, because it takes time to design this system and it takes a lot of work to design this system. Again, this system in itself is not completely possible in blueprints. I need C++ to make this happen, and going into C++ is something, if not advanced, it's intermediate. Okay, so you need at least 6 months of experience in Unreal Engine to know the ins and out of the system itself. Okay, like what notifies are, how montages are played, what the animation system is. These informations are really important, and most important is to know how to debug in Unreal Engine, right? In blueprints and in C++. So in blueprints you have the print strings to debug. In C++ you have the UE logs, you have the G-engine add-on screen messages. Okay, and debug spheres, debug all kinds of things. Like there's a tons of ways to debug. Okay, so you have to know how to do these before you actually go into my system and work on it. Okay, otherwise you will really have a tough time with it. So anyway, moving forward, um, one of the subscribers joined into my Discord server and he's facing this issue, is where actually when he's playing, right? So when he actually does these attack animations and the hit montage that is being played by the grunt, okay, they are actually like way off in terms of the play rates. Okay, so what's happening for him is, so like let's say he hits this guy and he does the damage again, right? So what happens is his montage hit montage is way longer than his attack montages. Okay, so what happens is, if he attacks the enemy, okay, he attacks the enemy, the hit montage is playing. Okay, now by the time the hit montage finishes, he can actually attack again. So he tries to attack again, but by that time, before he lands the punch, or just after, like let's say 0.2 second after he lands the punch, right, the AI actually calls in the stop enemy control. Okay, in the enemy component, it calls the control enemy logic, sorry, it calls the control enemy logic. Okay, it calls the stop as false, and the start logic plays just 0.2 seconds after the stop logic. So what happens is, when the start logic comes into play, the AI is like trying to move, and he plays the attack montage, and now the enemy also tries to actually play the um, hit montage, right? But he's also moving, and that way it actually like looks way off. Okay, so now that is where the problem comes in. Now to solve the issue, he basically has to actually go in and fix the play rates, make sure that the montages are in almost comparable uh, times. Okay, like if the attack animation is 1 second, the hit montage has to be 0.9 at least, I mean at max, right? So things like that. But also, I mean, that's not the only solution. Okay, now that is the best case scenario and how this system is made, and I'll show you two other ways how you can overcome if your hit montage is actually longer. I'll show that right now. Okay, so for that, what you'll have to do is go to the enemy component, right? And over here we are setting it out on blend out, right? The control enemy logic. So what you can do is you can actually use a set timer by function name. Okay, and from here you can actually like do from interrupted, blend out, and completed. Okay, now from here, let's say I'll make another function, and this one will be start logic. Okay, start behavior tree logic. Okay, and again copy this name, this has to be same, and after 1 second it has to be the start bt logic will start be called. Okay, so I'll call this start bt timer handle, and basically in start bt logic you will just call this function. Okay, and now go back to the control enemy logic. Over here, if it is true, you will clear and invalidate the timer, right? And that way the false will not run, right? So what I'm doing, understand this over here, is okay, now this will actually like fix the issue of like, let's say even if you hit the enemy and the enemy actually like gets the call like after 0.2 second, it will actually like stop it from calling the stop function, right? Because it will call the because it will call the stop logic, and it will basically clear out the timer. And clearing out the timer means basically this function does not get called, the false part does not get called at all. Okay, so that's how we fix this issue. Another solution, okay, would be to by using the anim notify. Okay, so like we have created the hit enemy, you will create the notify, not a notify state, because you only need one notify. Okay, so just from here you will have the enemy component and just call the stop function, not stop, enemy control enemy logic. You'll just call the stop function and just return it. Okay, and use it anywhere in between your hit montages. It could be anywhere, like let's say if it was the forward, let's say your animation montage was way too big, so probably you would want to call it over here, right? Like just add notify, and you would probably call it stop enemy, you would call it over here, right? And basically that would be it, and it would get called before. So yeah, that's also a solution. So with this issue fixed, and like after going through this part, let's move on to our next part, that is the AI director. Okay, in this before creating the AI director, um, we require I need to actually change a few things. First is the check for target. I'll actually change the logic for this. Yeah, there we go. So over here, I would actually, we don't require any of this. We don't need the target actor either. I'll actually get distance. Sorry, get blackboard value as actor. I'll make sure it is valid. Okay. And control pawn. I'll get the distance to the target actor, and basically I will set blackboard value as as a float, right? And that will be the value, and the key itself would be bb key underscore distance to target. Make sure this one is instance editable. Okay. And if it is not valid, I would set it to 0. Okay. Basically that's all for this. I will also rename this, call this check for target distance. Okay. And now let's go to the BP grant. Okay. And over here you will see the AI perception that we have added before. Now if you go to the details panel and go down, you will see there are some events that you can actually like override. Okay. The first one being on perception updated. Let's look into this one first. Okay. So now if I do a print string over here, right, it will say hello. Okay. I'll change the color and make it to 10 seconds so it stays for a little bit longer. Now let's play, and you can see it calls 1 2 3 4 5 6 7 8 9 10 11 times. Okay. Now why 11 times? Okay, sorry. Yeah, now why 11 times? Let's see. So this guy sees this one 1 2 3 and 4. Okay, so that's 4. Now this guy is a bit in front, so he doesn't see that guy over here. So 4 first and then 3 first, that's 7. Now this guy sees these two, that is 9, and this guy sees this one, so that is 10, right? 4 3 7, 2 is 9 and 1 is 10. Now where is the one more? Do I have something over here? One 2 3 4 5 6 7 8 9 10. Now it's 10 actually. Yeah, so basically that should be the case until unless he sees me. Like as you can see, this guy sees me and then he loses me, so there's hello twice, right? And now that is the issue with this part. I'll close the rest so it's easier to follow through in the BP grant. So now this is the issue with this. Like you will get an array of actors like he has perceived, but you will not know if he has seen the player, he has sensed the player, or if he has lost the player, right? So that is one of the issue with this on perception updated. That's why we have the on target perception updated, because along with the actor it has perceived, it will also give me a structure called the AI stimulus structure, and this one contains a few data, and including them is successfully sensed. So now if I remove from there, now if I say append successfully sensed player, Actually, yeah, I'll do a branch. And the first one, okay, successfully sensed is the uh, whoever actor was sensed, right? And in false, I'll do lost player. Okay. Now if I play, now see, sorry, yeah. So as you can see, sensed BP Grant, Six. So all the names of the enemies that it has sensed is being given over here, right? Now, if I do another condition over here, which we were doing initially, is the get player character. If it is the character itself, right? If it is the character itself, only then tell us if the character was successfully sensed or if he was lost. Now see, sensed BP player, both of these guys have sensed me. Now both of them have lost me. Now again, this is a good start, right? But it's not enough yet, because I don't want them to lose me just as soon as I move out of their field of view. I want a timer, right? So again, I will use a set timer by function name, and this one, check if target lost. Okay. Now again, I'll delete this one. Okay. You keep the function name. I'll give a 2-second delay before the function is called, and I'll promote this to a variable as well. Target check the timer handle. Okay. And after 2 seconds, it will play again, and we will clear and invalidate timer. Okay. And that one would be this target checker timer handle. Okay. Now I will take these two, actually these three. Okay. Check if target lost. I'll paste it over here, and I know that since I'm only checking for get player character, I will, if I lose, I will only be losing the player character itself. So now let's say in 2 seconds, so he was sensed after 2 seconds, sorry, lost, it should be lost. So sensed. Now if I go out after 2 seconds, yeah, lost. Now sensed again, I move out, but I come back again. See, one of them lost me, but the other one sensed me back in. So, and he does not actually call the lost player. See. So if I'm back again within 2 seconds in the field of view, he will not lose track of me, and which is a good thing. Okay. So over here, what I'll do is I will get blackboard. Okay. Now the target can be self, since it takes an actor. The actor can be character base as is. Okay. From here, I will set blackboard value as an object, and this object value you can set it as player character or actor. It's your choice, doesn't matter. For now, make literal name. Now this name I will get from the blackboard itself, that is this target actor. Okay. And in target lost, I will set it to none, and that's it. Okay. And over here I can actually like just type in get blackboard, get blackboard value as an object, literal name, and get display name. That's it. So now if I go ahead and paste the apostrophe, you can see target actor is invalid. Now it is valid. BP player. Now I go out after 2 seconds. Actually it rotates towards me, so yeah, obviously um they will not lose me right now until and unless I jump over them and they lose me. But then again, it won't be more than 2 seconds, right? Which is fine. I mean, that's what we want for now. Now another thing is the nav mesh itself. Mesh bounce volume, sure it's covering up the field. Yep. Now behavior tree, query, wait 10 seconds. What happened to the nav mesh? Volume. Right. Make sure, yeah, the nav mesh is properly set. Yeah, there you go. Now they are moving in. So I had the nav mesh above ground. Okay, so sorry about that. And as you can see, they are moving, which is fine. Now we have it where we had before, which is perfect. But now to upgrade it a bit is distance to target. We need to make a value for that, variable for that. It will be of the type float and it will be called distance to target. And over here I'll set it distance to target. Okay. Now depending on this distance to target, we want to set a few states, right? And these states will actually be enums. Okay, and for that again we need to go C++. So I'll open up the SLN, and while that opens I'll save all and close the editor. Okay, and now once it has loaded in, I will actually make a new enum. Okay, I'll call it enum blueprint type enum AI states. Okay, and it will be in 8. And now in my last lecture I told you guys that we can also write enums without the display name, right? So I'll write this one without the display name and the umeta. Okay, so the first will be if I am far away, it will be get in range of the enemy of the player. Okay, now if it is too close, we will say get back from the player. Then if we are in range but it's not our time, we can either wait, we can look for weapons, or we can just strafe around, right? So we can do these kind of things. So for now these 5 is enough, and the last enum does not actually have a comma, remember that. Okay, now let's go ahead and run this. And once this is done, we will create a new task. Okay, I'll call this btt underscore set AI state. Also another thing is I'm keeping the btts under behavior, it should be under logic. So let me create this, and then I will go to logic. There's the task folder. If you don't have it, create it, and I will move all of these to the tasks folder. Okay, and over here I'll override the execute AI, and I will get blackboard value as an actor. So it will be bb key underscore no, this one will be a distance to target, and we don't want that, we want the float, right? Get blackboard value as float, that is distance to target. Make sure it's instance editable, and now if it is less than let's say 300, right, we want to go back. Now this will be AI state, and we named it AI states, right? So I'll set it to get back. Okay, and after that I'll set blackboard value as an enum, promote this to a variable, we'll call this bb key underscore AI state. Okay, make sure instance editable is set, and the value would be AI state itself. Okay, now the second would be if this is in range. Okay, now what I'll do is I'll promote this to a variable and call this get back range. Okay, I'll make sure it's instance editable, and by default it is 300. Okay, and then I'll make 2D make vector 2D, sorry, not make, break vector 2D. Okay, and x would be minimum, y would be maximum. So promote this to a variable, and this will be in combat range. Okay, make sure this is instance editable as well. By default let's say it would be 300 and maximum 2800. Okay, and yeah, so from here, if it is true, I will choose a random array element, and this one will be make array. So if it is in range, I'll either wait, look for weapons, or strafe. Okay, and then again from there I'll go to this, and if it is false, I will get in range. Okay, so all 5 values have been set, and since this is an execute AI, make sure you finish execute and set it to success, otherwise it will never get out of the task. And now what I can do is I can make a sequence. From the sequence there will be a selector, the selector, this will be one of the choices, and in the sequence itself I will call the set AI state. Over here make sure distance target is distance to target, AI state is, wait, to go to the blackboard, make a new enum and call it AI state. And now if you go to key type, you will see that all of these are actually blueprints, right? So now you might be thinking, how do I use C++ ones? If you go to the enum name over here, you will see the name of enum defined in C++, okay, will take priority over assets, okay? So basically, you'll have to get this name over here, copy it, and paste it over here, and it will automatically set the enum thing, okay? And select that AI state, and once that is done, we have the selector, and from the selector itself, we'll add a decorator. Blackboard will make sure that the AI state is equal to, if it is get in range, we'll do this. We'll do the same thing for now for strafe as well, okay? So if it is strafe, we'll do the same thing, but for the rest 3 of them, we'll just do a wait now for this lecture and get back to the logic for the rest in the next lecture, okay? So if I'm strafe, like no, sorry, this one will be wait is basically wait, yeah, doesn't matter. Look for weapons and get back, okay? For now, all of these will be wait. And also set focus, so you can, the enemy looks at you even while they wait. And another thing is, since we changed the selector, the sequence over there, the observer bot has changed as well, so make it back to lower priority. Now if I play, I'll select this one. Now you can see AI state is actually get in range at the moment. If I am close, as you can see, the distance to target is 334, so it is more than 300, so it changed to wait. If I get way too close, now it says get back, right, which is working. Now yeah, over there, if it is in range, now it randomly chose to strafe. After the time remaining is done, it should actually choose something else again, that is wait. And after the time again, look for weapon C. So different things. Now if I go above 2800, actually, I mean, that is way too much, but you get the idea. So if it is more than that, they will definitely now, yeah, see, now it is more than, now it's calling get in range, see. So basically it's working, our AI states are working. Okay, so now let's go ahead and make the AI director, and before we make that, I want to explain how the director will work and how the behavior tree works, okay? So the behavior tree in itself does not actually control the attacking and the counter system, okay? The counter system is dependent on the counter system, and the attack system is dependent on the AI director itself, okay? So when it's their chance to attack, the AI will again stop the behavior tree logic. It will go to the AI director. The AI director will tell them to move to the character and then use root motion warping to attack the player. And if the player counters, it's a counter. If not, it's a hit. Okay, so that is how the AI director will actually work. And how does the AI director do a bookkeeping of it? That is what I'm going to show you right now. Okay, that is the base that we'll be creating in this lecture. Okay, so let's go ahead to the FFCC blueprints, and this AI director will be under components because we will add this inside of the player character. Okay, this will not be a scene component, this will not be placed within region, okay, like I have seen most people, most YouTubers do actually for their own system. I mean, that is very much a linear system, and you cannot use that system in open worlds because let's say you have AI in maybe this is area 1, this is area 2, right? You have these AIs over here, and the AI director they are using is this one, and this region has another AI, and they have director 2, right? So if you bring these enemies over there, now there's like two different AI directors, and both of them working in a different way, and it doesn't actually like seem that optimized from my perspective. Okay, so I'll actually make this system live inside the BP player. Okay, so let's go ahead, create the actor component class. So AC underscore AI director, and right now we'll have two functions. This will be add enemy, and another would be remove enemy. Okay, now both of them will take in inputs of enemy reference. Now these will be actor classes. Same for the remove enemy reference. So in the add enemy, what I'll do is I'll promote this to a variable, delete this. I want this to be an array. Okay, and what I'll do is I'll use a add unique. So what is the difference between add and add unique? In add, you can add the same reference of the same enemy reference twice into the array, right? So let's say BP grunt underscore 0 gets added twice because he has been perceived because he has perceived the player twice, right? So you can add it twice if you just if you use the normal add. But add unique means there is a check already that does this enemy reference already exist in the array? If it does, it will not add it back again. It will just add it only once and that's it, leave it. That's why we'll be adding unique in the add enemy, and in the remove, there's just remove item. That's it. If it exists, you remove it. If it doesn't exist, don't remove it. That's simple. Okay. Now, this is all that we need for this lecture. Okay, for the AI director to work. Now let's go back to the BP grunt, and over here, after over here, set value as object. So over here, what we'll do is we will get value as an object. Okay, from the target actor, we'll make sure it is valid. Actually, yeah. I'll make sure it is valid first. Then I will get component. Okay, let's get component by class. Now it takes a target actor, and this is object. So obviously, I need to cast to an actor class at least, but I'll just directly do a character. And I know this will be a pure cast because targets will always be a character class. Okay. Now from here, I will get the AI director, and over here, I'll do another check that it is valid, that the character class has this AI director. Okay. If it doesn't, it's fine. I'll still remove it. But if it does, I will remove the enemy. Okay. And the enemy reference would be self. And then I will set the value like that. Okay. And in target perception over here, from here, what I'll do is, now this is an actor, obviously. So I'll get component by class directly. I will again get the AI director, make sure it is valid. If it is not valid, that is fine. But if it is valid, if they have our AI director, I will add enemy. Okay. And again, the enemy reference would be self. Okay. And in the AI director in text, I'll do a print string, and I will do an enemy reference. I'll get the length. I'll print it out as red. Okay. And I'll make it 0. So every frame there's only one output. So right now it is 0. Once it has sensed, right. So what I'll have to do is I'll have to make sure that I go to the BP player and add this AI director, right? So once that is done, it's 0. Now it is 2. Two of them have seen me. Now that's 3. As you can see, is waiting. And 4, and now 5. So our AI director has 5 AI references. Okay. And in the next lecture, we will see how one of the AI gets picked up to actually, no, sorry, not in the next lecture. Next lecture we'll do the different states of get back and stuff like that, and then I will do the attack. Okay, how the AI director actually picks one of the AI to go and attack the player. Okay, so I think this video is already big enough, and actually it covers all the things that are very much important to the AI base itself. Okay, so yeah, I'll end it over here. So thank you guys, and as always, if you want to support me and the work that I'm doing, you can subscribe to my Patreon. It starts from just $1 a month. Okay, and also there are different tiers based on the needs of different people. Okay, so do check it out once. Thank you.